There's two topics that we'll cover today: code readability and code structure. I'll do the slides for each section individually, just so we've got an overview before going into the code along section. And as always, feel free to ask questions in the chat at any point, or if you'd like me to repeat anything, just let me know. Sometimes I can't see the chat, so if you want to just shout out, that's fine as well. Okay, code readability. Why write readable code? It's pretty much so that you can understand it in future, or if someone else comes onto your project in future, they would be able to understand the code that you've written. So throughout the session today, kind of the question that we'll come back to is, if I reread this code in a year's time, will I be able to understand what I've done and why? And if you can, then for scientific code, that's a real success, because one of the main issues that we keep falling into is coming back to old scientific code and spending so much time trying to understand what it does before you're even able to run it or add to it. And there are a few different ways that we can improve the readability of code. I'll talk through them now, and then we'll see how we can actually implement each of these into the Spacewalks project from yesterday. First of all, putting the import statements at the top. So you might have seen they were dotted throughout the code yesterday, but placing these at the top means that it's clear what the dependent libraries are of the software before you get started, so they're not buried inside the code. Using meaningful variable names. You'll have seen in the code yesterday there were names like T and W and J, which are totally non-meaningful. So using short words rather than single character names. And if it isn't possible to describe a variable with a meaningful name, because it would just be too long, then using an inline comment. There are also certain rules for naming variables based on the language that you're using, and we'll look at some of the rules for Python, because that's the language that we're using in this project. We'll look at removing unused variables and imports. So I think somebody spotted yesterday that there was a variable that we weren't using. So we're going to clean all those up so that the code only contains what's actually used, making it a lot more readable, hopefully preventing confusion and any errors. And this is maybe one that you wouldn't think about with code readability, but using third-party libraries rather than writing everything from scratch. So yesterday, the Spacewalks code read in the data line by line. And while this works, there are standard libraries like pandas that are reasonably well known within the scientific community, and mean that you can just use one line of code to reliably do the task at hand. So making sure that we're choosing the right tool for the job rather than writing everything out from scratch ourselves. Using comments to explain any functionality. This is maybe one of the more obvious ones, but we'll talk about how you can write a helpful comment, so focusing on why the code does something or how it does it rather than just what it does. And one of the most difficult bits maybe of code maintenance is keeping the comments and the documentation up to date if your code changes over time. We will look at separating things out into different units of functionality. So yesterday, in our Spacewalks code, everything just ran from top to bottom, but there weren't any functions within the code. And this means that the code will be, firstly, incredibly hard to test, and it makes it less readable if we have to really look through all of the code to find the bit that we're after. So we'll today split the code up into functions, where a function is an isolated section of the code that performs a specific task. You can call it them multiple times within the code base. So this naturally follows the rule of don't repeat yourself. And but it's so you only need to define it once and you can use it multiple times. And then I think this is the final one, using doc strings to document functions. So we'll have already talked about comments, but doc strings are specific documentation for functions. So explaining what the code's doing, the parameters the function needs, what the function outputs, and any errors that we might expect to be raised. Okay, so that was just a quick overview of the plan for today. So most of it's going to be working in the Spacewalks directory. So if you want to go ahead and open that up now, maybe I'll pop oh, if I can see the chat, I will put a comment in the chat. Ah, I'm not used to Zoom. Does anyone know how I can see the chat while I'm sharing my screen?
Oh, there should be a chat icon next to participants icon at the bottom.
If you have the floating bar that it sometimes hides where it might show.
Maybe there is a more button if
Okay,
it's
let's
hidden.
see. Got it. Thank you very much. Okay, let me just do some screen rearranging. Okay, so I'm just going to put a question in the chat saying I have opened the Spacewalks folder in VS Code. So if you can, oh, we did the green check marks yesterday, didn't we? If you can give me a green check mark when you've opened the Spacewalks folder in VS Code. Excellent. I'm seeing 11 ticks. Fantastic. Um, and the other thing to do before we start today is to activate the virtual environment from yesterday. So as a reminder, that is source, and then if you're on Linux, it will be source fem spacewalks /bin/activate. Or if you're on Windows, like I am, it will be source fem spacewalks /scripts/activate. And you should then see the venv spacewalks next to your prompt. Okay, so keep the green check mark up if you've activated the virtual environment. If something's gone wrong, or you need another minute, if you react with a red cross. All good. I can see 13 green ticks. Fantastic. Okay. So if we have a look through our script again, the first thing that we might notice is that the import statements are dotted throughout the code. So they're pretty much imported just before we need to use them. And it's a convention that we put the import statements at the top of the code to help with the readability. So I'm going to do that first of all. So if you're coding along, if you follow along with me, let's move all of our import statements to the top of the code. There we go, imports here. So you can see for me they were even difficult to find in the code when I knew what I was looking for. Whereas now we've got them moved to the top so that anyone running the code can see which packages are needed, so they know which packages to install. And as we've now edited the file, we need to keep the Git repo up to date. So I'll save that file. I'm using Control S to save, in case anyone's unfamiliar with VS Code shortcuts. I know I used to go file save and it took a long time. So Control and S is a shortcut, or I guess Command and S on a Mac. And let's git add either data analysis.py. And I'm getting this warning here. This is because I'm on Windows. If you're on Windows, you will likely get the same warning. For our purposes today, you can just ignore it. It's telling us that Windows is using a slightly different type of line ending than the one that's used in Git. And once we've added that file, we can git commit -m, and we will say we have moved the import statements to the top of the script. Okay, I can see I've got one file changed, 5 insertions, and 6 deletions. So before I go any further, can I check that my text is large enough for anyone, or would anyone like me to increase the size? All okay?
All good.
Excellent. Fantastic. Oh, one increase if possible. Yeah, let's make it a little bit bigger. Um, is that all right now? I know it depends what size screen you're on. So if you've got a second monitor that you can watch this on, it's obviously going to seem a lot bigger than if you're trying to fit things onto a small laptop screen. Perfect. Okay. So we've already made our script a little bit more readable by moving the import statements to the top. The next improvement that we'll make is to use some more meaningful variable names. So as you know, variables are a really common thing to use while coding. And therefore, we need to make sure that each variable it's clear what each variable means so that we can understand what the code's actually doing. This means that if you return to your code after a long time or you share your code with a colleague, it should be clear what the variables are from their names. There aren't really any hard and fast rules regarding variable names, so quite often it's just a case of using your best judgment. But some tips are that generally single letter variable names are difficult to understand. So here, J, T, I've got no idea what any of those means. So it's much better to use a short word rather than a single character. So as an example, if we were creating a variable to store speed, rather than using S for speed, or using something, rather than just using S for speed, we might use read underscore speed or something like that. Generally, the rule is if you're finding it difficult to come up with a short and descriptive name, go with the shorter version and then just leave a comment as well explaining what the name means. Then in Python specifically, there are a few more considerations. So Python only allows us to use alphanumeric characters and um, underscores in variable names. And but you can't begin your variable name with a number. So you could use x2, but you couldn't use 2x. So um, so yeah, that's another example. Read speed 1 is valid, but 1 read speed wouldn't be valid. Uh, if you know Python, you'll know that variable names are case sensitive. So if you capitalize the first letter of a variable, that will be seen as a different variable than if you'd written it all in lowercase. One final thing is that often programming languages will have inbuilt functions. So you want to make sure that you're not overwriting a function by giving a variable the name of that function. So in Python, you might have input as a global pre-built function. And if you accidentally overwrite this by assigning a variable to the name input, um, then you wouldn't be able to access the original input function. But I think Python would give us an explicit warning if we tried to do that. Okay, so this bit's over to you. We've got a challenge to rename our variables to be more descriptive. So I think that um, uh, Alex, are you on copying and pasting?
Um, which exercise? Sorry, do you want me to paste the exercise?
Oh yes, please. It's so we're on rename our variables to be more descriptive.
Yep, will do.
Thank you very much.
Just give me a second. Right up.
So this challenge is basically to rename our variables throughout the code. So there are a few where you've been given the updated variable name. So changing data F to input file, data T to output file, and G file to graph file. And then there's also a section where you've been asked to rename WT, TT, and TTT without any explicit name to rename them to. So in that case, it would be a case of looking through the code, trying to figure out what these variables do and renaming them accordingly. If you're not sure, then you can just wait and I will show you the solution. But have a go at figuring out what these variables actually do so that you can rename them. Okay, fab. Thank you very much, Alex. So the exercise has been pasted in the CodeMD. So if you take about 5 minutes to have a go at that challenge, and then we'll go through the solutions. That's been about 5 minutes, so we'll go through the solutions. First of all, we're renaming data F, data T, and G file to input file, output file, and graph file. So you can do this manually by, and then maybe you can use Control F to search for any other instances of data underscore F to make sure you update those as well. Another function in VS Code that you can use is if you right click on the variable, um, can you see this pop-up menu on my screen or does it? Yeah,
Yep, that's
perfect.
true.
Then if you go to rename symbol, you're able to rename all instances of, in this case, data T to output file. And we can verify that by seeing further down in the script that this has been done. So I'm going to do the same with G file. Right click, rename symbol, and change it to graph file. Okay, then the next part of the challenge is maybe a bit more difficult. So renaming the variables. Oh yeah, I can see a hand. Jen? Oh, sorry, I can't hear you. Right click on Linux. Okay. Maybe are there any other Linux users out there who might be able to help? Uh, Steve, are you a Linux user? Do you?
I can be. What was the problem? Sorry, I missed that.
That's all right. So I was just showing how you can rename a variable by right-clicking and then selecting the rename symbol option.
Mm,
Um, but there's no right-click option on Linux. Is the problem?
that's an interesting one. So I'm using Mac now, but I can boot up Linux on my laptop and have a look.
Before you do that, I can see that actually there's an F2 next to that. So maybe try, it looks like the keyboard shortcut might be F2. Give that a go and see if that works. Thank you for the offer though, Steve.
No worries.
I wonder otherwise if like there's a search option for like that command or some setting that might have a different just key or menu for Linux.
Potentially. Did the F2 work for you, Jen? No luck yet. Maybe one of the helpers could investigate, and hopefully we'll be able to come up with a solution for you. Okay, so just out of interest, what did does anyone want to volunteer what they renamed any of the variables, any of the other variables to? Either WT, TT, or TTT?
I went for a CSV file for W because I wasn't sure what it was for first. But
Yeah, that's that's a fair decision because it's a CSV, yeah, sort of a function for handling CSV files.
Mhm.
Great. Yeah, so it is actually quite difficult to come up with variable names for especially if it's for code that you didn't write and that you don't fully understand. So what we could do is change W to CSV writer to make it clear that this is the CSV writer object. So I'm going to use that shortcut again, rename symbol CSV underscore writer. Has now been updated throughout our codes. Then we've got this TT variable, and this is selecting the what's it even selecting? The duration column of the J element of data. So this is giving us duration as a string. So we might call it duration underscore str. Then we've got a single T, and we can see that in this case, we're taking duration string and we're taking out of it the time in hours and minutes and creating a date time object from that. So we might call T date time duration underscore DT to stand for date time. And then finally we've got triple T, and here we can see that three T's is creating is converting the date into decimal hours. So we'll get just the number of hours that was the duration of the spacewalk. So one more time, rename symbol duration underscore hours. There we go. Okay, so you can see that was a bit of a headache having to try and figure out what all of the variables did and then renaming them. Whereas if we'd started with these nice, clear variable names, then it would have been a lot clearer. So we've made some changes to the file. Let's save it again with Control S, and then add commit and commit our changes and push up to GitHub. So git add eva data analysis.py. Git commit -m. And this commit will make it use descriptive variable names. You can git push origin main. Okay, so so if you have made those edits to the variable names and push the changes up to GitHub, if you can put a green tick on. If you need a few more minutes, if you put a red cross. And if you have a question, please feel free to ask.
Do we have to git push origin main, or is it git push enough here?
I think git push would work. Yeah,
Okay.
origin main is really just being more specific about where you're pushing to. But in this case, we only have one origin, and we only have one branch. So that is
Okay.
the only place we're going to be pushing to.
Okay, so this is where we would choose the branch we're pushing into, right?
Usually you would, I think we have some more information about branches later in the course.
Okay. Okay.
But yeah, usually you would change onto the branch that you want within your within your code before you push. So yeah, so just saying git push in this instance would push it up to where you want, but we're being really specific about where we want the code to go by saying git push to the origin, to the main branch.
Okay, thank you.
Yeah, and as Alex said in the chat, it's good practice, and this is, of course, all about good practice. Okay, fab. I can see we've got 7 thumbs ups. Oh, 8 thumbs ups. I think we had a few more earlier, so if there are any problems, please do feel free to ask. Great, we've got 12 thumbs ups, which is, I think, the amount that we were expecting. Great, so we've now updated all the variable names to be more descriptive. And if you remember yesterday, we actually created an issue on GitHub for this. So what we can do now is open up our repository on GitHub, find the Issues tab, and close the issue. So if you head on over to GitHub, make sure you're signed in so you can see your profile up in the corner. Then navigate to the directory, to the repository that you were in yesterday. So just, I did that quite quickly. If you go to the top right, click on your profile, then click on repositories, it will take you to the list of all the repositories that you own. Now, I called mine Spacewalks May 26 because in running this course before, I'd already created a Spacewalks, but yours should just be called Spacewalks. So we'll click on that to open it. And as you, if you remember, there are these different tabs at the top of the repository, and the one over from code says issues on it. So let's head over to the issues, where if you were following yesterday, you should have an issue called improve variable names. And here we said rename the variables WT, TT, and TCT to be more descriptive, which we've just done. So we can go ahead and close that issue. Now, if I head to issues, I don't have any open issues, but if I click on closed, I can see the issue that I've closed with a nice purple tick next to it. Okay. So our code's looking much better already. We've got the import statements at the top. We've got some more meaningful variable names. But as someone noticed yesterday, there is a variable that isn't used. And if we have unused variables in the code, it can cause a lot of confusion. I know that I've received code from collaborators before, and I've been searching for a particular variable, trying to figure out what it actually does, only to find that actually it's not used anywhere, and it had become redundant but just been left in the code. So you can save yourself in the future and collaborators a lot of time by removing anything that's unused within your code. So this is another challenge. So it's over to you to find and remove the unused variable in our code. Then commit the updated code to the GitHub repo. So if everyone removes your green ticks for now, and then when you found the issue, removed it and committed the change, if you pop that green tick back on there. Just a reminder to put a green tick if you have found the unused variable. Okay, perfect. Looks like most people have found it. So can anyone volunteer in the chat which variable was unused? Um, File names. So it may have been a typo. It was field names. Yeah, so that was unused in the code, and we can verify that by we can search for field names and see there's only one instance of it. So let's go ahead and remove that variable, save the file, and then we'll add and omit the change. And just in case anyone hasn't come across tab completion before, there I started typing Eva data analysis and press tab about halfway through, and it will complete the file name for you, which is very handy, saves a lot of typing. And then git commit -m, remove unused variable field names. Or git push origin main. Okay, so there we found the unused variable manually. We looked through and saw which variable was defined but then never used. But there are tools that can do this for us called linters. So there are quite a lot of different linters. Two that I've used previously are PyLint and Flake8. There are also linters called Black and Rough. Has anyone else come across or maybe used a linter in the past? So I'll just pop in the chat a link to PyLint, which is one of the linters. Generally they will, if you run a linter over your code, it will tell you if there are any formatting or styling issues according to a certain set of styling conventions. And this it can be really annoying because every time you want to save your code, you have to edit the code to match the style according to the linter. But that annoyance is actually a really good thing in the long term because it forces you to keep your code consistent and in the same style and clean as you're developing it. I'll also pop in the chat Flake8. So these are two links to look at later if you are interested in using a linter on your code. Another thing, even if you don't have a linter, if you're not running a linter on your code, and I've just realized I should probably explain because this didn't occur to me for a while. They're called linters because the metaphor is like lint that comes off your clothes. So you might have a lint roller where you roll it's like sticky and you roll it on your clothes and the lint comes off. So it's like that, but for code, you're trying to get any untidiness to stick to the linter to come away from your code. But even if you're not using a linter as such, then IDEs such as VS Code can really help enhance your code readability by enforcing style. So they do this by enforcing some coding standards. So for instance, if I were to do some wrong indentation here. VS Code is telling me with a red squiggly line that it's not acceptable. And I think if I click on this yellow light bulb, I have the options to fix. I think that's AI. Okay. It's telling us anyway that that something is incorrect. And when I indent it correctly, red squiggly lines go away. It also does this syntax highlighting, which is quite helpful. So the different parts of the syntax are highlighted in different ways. So here we've got functions in purple, we've got variables in white, we've got objects in green, brackets in yellow. So all of this is to help us read the code more easily. And I think it's easy to take it for granted if you're using an IDE all the time, but then if you go back to using something like Notepad, you definitely notice how helpful it is to have the different colours there. Another thing that's helpful in VS Code is quite often can have intelligent code completion and ways of dealing with variables. So one example is when I use that function to rename all the symbols in the code, massively helpful. And there are some things like if I start typing, VS Code will suggest to me all of the things that it thinks I might want to type the based on the code in this file. So here it's identified that there is this variable data, and it's suggested to me that I might want to write it. So there are lots of features. I haven't gone over hardly any of them. To be honest, I probably only use maybe 20% of the features that are available, but it is useful to spend a little bit of time exploring VS Code, looking at these different features that are there to make your life easier, basically, and to help you improve your readability.
How do you use the lint? Do you activate it as an extension or
But for the link, also, I'm getting a bit of feedback.
sorry.
Is that better? Yeah. So for the linter, it's like a package that you install, and then you would run it over your code. So just like we installed matplotlib yesterday, we'd install pylint and then use its functions to lint the code. Also, quite often, these linters are used as part of a continuous integration pipeline, which Steve's going to talk about tomorrow. So in this way, every time you push your code up to GitHub, the linter would be run on your code, forcing you to keep in check with those standards. But yeah, if it's the easiest way to get started with the linter is probably to install it as a package, make yourself familiar with the functions that it has, and run it over your code.
Thank you.
No problem. Okay, we're coming up to an hour of the workshop, so it's probably about time to take a break. So let's have a break until 10:15. And if you have any questions about anything so far, then feel free to drop them in the chat and I'll answer them when we come back from the break. But for now, let's take a 15-minute break. Okay, I hope everyone had a nice break. So, if you're back, if you could just put a green tick mark so that I know when we can get started. Okay, nice. Looks like most people are back. Are there any questions before we keep going through the rest of the materials? Feel free to pop any questions in the chat, or unmute and ask. No, if not, let's keep going then. So, if you remember so far today, we have moved our import statements to the top. We've renamed the variables to make them more meaningful. And just before the break, we found the unused variable in the code and removed that. So the next change that we're going to make to the code is probably the largest. The most fundamental problem with the code really is that it's trying to do everything from scratch. So at the moment, it reads the data in line by line from the JSON data file, and then it uses custom code to manipulate the data. We're storing our variables of interest in lists, but not using the data structure that's probably the most useful for this kind of data. So this would be something like a pandas data frame. So what we're going to do now is convert the code to use a popular and well-tested library pandas. And in doing this, we're going to make our code more readable and understandable, and also less prone to errors. Because all of this code from the third-party library has already been tested, and we can rely on it. So it's going to make our bit of code more robust. But before we can use the pandas library, it is a separate package, so we're going to need to install it into the virtual environment. So in the terminal, I'm going to say Python -m pip install pandas, and just making sure that our virtual environment is activated, which you can see from venv spacewalks in brackets there. Mine's just taking a little bit of time to install. Maybe some of yours are as well, just so we know when to move on. If your pandas has successfully installed, if you can put a green tick mark. Ah, there we go. That took a little bit longer than usual for me. I was starting to wonder if something had gone wrong, but it looks okay. And it looks like most other people have installed pandas. I'll just wait another 30 seconds or so. Or maybe if anyone is still waiting for pandas to install, if you could put a red cross and we'll wait for you before we move on. Because I know it's totally out of your control when something's downloading. Great. Okay, let's wait another, well, however long it takes to install. Okay, perfect. I can't see any red crosses now. So we've got pandas installed in our virtual environment, and we're going to refactor the code to use pandas to read in the data and write out the CSV file. Now, this isn't a workshop about pandas, so we're not going to go over the syntax and everything. What I'm going to do instead is copy and paste the code using pandas into the shared notes document, and you can copy and paste that into your either data analysis.py. So I'm just going to Control A, delete everything that's currently in either data analysis.py, and I'll paste in the pandas refactored version. I can see that when I copied it across, I forgot to copy across the imports, so I'll add those in now. And you'll notice that now we only need matplotlib and pandas. We don't need JSON or CSV reader because now we're using pandas to do all of that. Okay, so we've replaced the code in our Python script to use pandas, and we've installed pandas in our virtual environment, but we want to make sure that that is captured within the requirements file. So if you remember from yesterday, to freeze, so if I were to say Python -m pip freeze, I should get a list of all of the packages that are currently in the virtual environment, and you'll see that that includes pandas. But then we want to actually direct this into the requirements.txt file. So Python -m pip freeze, and then a greater than sign to put that contents into the requirements.txt. Now, on my Windows machine, for some reason, because of the setup, I need to make my Python an executable for this to work. I'll just show you what happens if I don't do that, in case anyone else is in the same situation. So it's not allowing me to produce an output to make Python an executable. It doesn't seem to be the case for any for all Windows machines, but something about my setup means I have to do that. So if that's the case for you, then that's the fix.
Sorry, could you just repeat like really fast how to go to pandas? Like how to did you just copy everything? I think I got lost a little bit in
Yeah, no problem. So in that last section, we installed pandas into the virtual environment. Yep. Then there's we've refactored the code, but we've just done that by copying and pasting the new pandas code. So if you head over to the shared notes document, which I'll just pop a link in the chat. you head to the shared notes and then right at the end, so starting on line 245, you'll see we've got some code that's refactored to use pandas. So it's a case of copying and pasting that chunk of code into your either data analysis.py file. So you can remove everything that's there at the moment, just copy and paste that code in.
Okay, thank you. I missed that part. Thank you.
No problem. So once that's copied and pasted in, the other thing to do is to update the requirements.txt file. So you do that by running pip freeze and then redirecting it into requirements.txt. See, there's a question in the chat. Should you always be upgrading to the latest version? So I have a new version of pip available. Is the best approach to upgrade straight away, or is there a better time to do that? I think it's generally a good idea to keep pip up to date. It doesn't take that long to update. Yeah, I can see Steve's given a more in-depth answer. Thank you very much. Okay. Is there any element of that anyone would like me to go over again? I know it's a bit confusing because of the copying and pasting.
So after the copying and pasting, it's go to Python freeze, right? Is that correct? Freeze.
Yes, that's it. So just to recap that section one more time, I installed the pandas library, then I copied and pasted the code from the shared notes document into either dataanalysis.py, and this is a new refactoring of the code using the pandas library. Then I ran Python -m pip freeze to get a list of the updated packages that are in the virtual environment, and I directed that to the requirements.txt file. So we've made a big change. We need to make sure that we commit it to Git. So let's git add either dataanalysis.py. And we also want to add requirements.txt. So I've just added a space between those two files, but I can add them in the same statement. In git commit -m refactor code and add pandas to the venv. So two files changed. We've had 14 insertions and 46 deletions, which reflects how we've made our codes shorter and more efficient by using the third-party library rather than the custom code. So now we can push our code up to GitHub with git push origin main. So we've got our new code now using the pandas library, but it's missing any comments. As you may know, commenting is one of the best ways to convey information about the code. And it's helpful both for your collaborators looking at it, but also for your future self when you come back to this code in a week or in a year's time. It can be helpful in explaining why you wrote some code a particular way. So I know I've been part of projects, for instance, where somebody's come to some code a few years later and thought, well, why have they done that? This is silly, made the change, and then it's broken something else. Whereas if the person originally making that decision had written a comment explaining why this needed to be a particular way, it would have prevented the confusion. It can also help to explain the real world implications of your code. So putting things in context, for instance, if you were using a tax rate for some financial code, you might say you've set it as a particular value because the sales tax rate is this on this date, for instance. And there are a few different ways to add comments to code. I'll just demonstrate at the bottom of this script. So say, in fact, I'll make a new script so we're not polluting either data analysis.py. I'm just going to say new file, and we can just call it comments.py. So say I had x equals 5, and I wanted to write an inline comment about that variable. I could put a space after the code and then a hash symbol, and that would be an inline comment. I'd usually put a space after the hash symbol as well, just for readability. You can also have a single line comment if you're explaining a block of code. So I could say, this is a single line comment to explain the below code. And then I might have y equals x plus 10, z equals y times 2 plus x. These are all just random examples, so they don't, none of the variables here actually mean anything. This is just for demonstration. Then the final type of comment is a multi-line or block comment, and that looks a little bit different. We can do it with three quotation marks, and you can see that VS Code very helpfully auto-completed the second lot of 3 quotation marks here. Let's actually make it multi-line. So it spans multiple lines, and you can use either single quotes or double quotes. So that's the syntax, but what really matters about a comment is what it actually says. So sometimes you'll see some code that explains what the code does, but it doesn't really explain much beyond what you'd understand from just reading the code. So where possible, it's more helpful to write about the why and the how of the code. So as an example, if I had this state tax variable, and on its own, it's a bit unclear. If I was just writing about what the code did, I would say assigns the float 1.0625 to the variable state tax, which is true. But why is it doing that? it's not really clear. What would be more helpful is if I was to say I had another variable city tax, which equals 1.01. It would be more helpful to say the city tax rate is 1% in January 2026 to explain why I set that variable as I did. It's also helpful to include dates if your variables relate to things in the outside world as an indication of when this variable might need to be updated. Okay, so heading back to either data analysis.py, we've got another challenge now to add some comments to our code. For some reason, it's all gone grey in the shared notes document. Let me try and fix that. Okay, so if you head down to line 277 on the shared notes document, this is the next challenge. So have a read through either dataanalysis.py and add as many comments as you think is required to help yourself and others understand what the code is doing. And then commit your changes to your repository. Remembering to use an informative commit message because commit messages are also a kind of comment. They'll show people in future what's changed in your code and maybe why that's happened as well. Okay, so I'll give you about 10 minutes to add those comments.
Hi, Philly.
Hi, do you have a
Yeah,
question?
hi. Yeah, I do have a question. On line 10, uh, let's say, we have encoding ASCII. And then on line 16, we also again need to mention the ASCII encoding, and if so, why? So I did not understand. Thank you.
So here we mentioned the ASCII encoding. Oh, so is it we mention it here and then again here?
Yes,
So
yes,
looking at the code, I imagine once we've read it in specifying that the encoding's ASCII, Python or pandas will probably be able to assume that the encoding is ASCII again. But to make sure that it's definitely using that encoding, we've specified it twice. So
it's a good practice, is it, to make sure that
yeah, that's
okay,
it. So at each
okay,
step, we're specifying the encoding at each step, just to make sure that that's the encoding being used.
okay. Thank you. Thanks.
No problem. Just so I know when everyone's finished the challenge, if you could put a green tick when you've added your comments, that would be very helpful. Okay, I can see 10 ticks, so let's have a look at some comments that you might put in the Siva data analysis file. So here we've already got a comment with our the source of this data, which is helpful. We might want to put a comment before we read in the data to say, read the data from a JSON file into a pandas data frame. And then we have this drop NA function here, and we might want to explain what that does. So here we'll clean the data by removing any rows where duration is missing. The next row is saving the CSV file. And we might want to specify why we're doing that. So save the data frame to CSV file for later analysis. And after that, we sort the data frame. And we probably want to explain why we're doing that. So we can say, ready to be plotted with date values on X axis. So this will make sure that our plot moves forwards in time along the x-axis. And then finally, this last block of code is all to do with plotting. So we could say we want to plot cumulative time spent in space over years. So now we've got some comments to explain what our code does. Something else which can be quite helpful, particularly if your code takes a while to run, is to add some print statements periodically throughout the code, so that you know which stage your code is at. So I might say, before anything's run, we want to print start. I've just put it in capitals and added the dashes to make it clear to see in the terminal. Then we may want to print, sorry, using an F string so that we can include Python variables, reading JSON file, and then the input file. Okay, so we've added a couple of print statements there. We might also want to add one before we save the file. And we might want to add one before we do some plotting as well. Finally,
Hi, would you mind?
one.
Sorry, would you mind going back to? I got a little lost. Would you mind going back to The print start at the top. Okay.
Yeah,
Yeah,
sure.
sure. So,
Sorry.
Oh,
oh,
bit of
bit of
feedback.
feedback.
Okay, so we printed start, and then we printed reading JSON file, and we included the input file in curly braces. And we can do this because we're using something in Python called an F string. So we put F before the opening quotation mark, and this allows us to include Python variables in curly brackets within the quotation marks. Then the next print statement, I have said print saving to CSV file. And then finally, before we create the plot, I've said print plotting cumulative spacewalk duration to graph file. And the last one I'm going to add is print what I'll do is I'll paste into our shared notes the current state of the code in case anyone would rather copy and paste than try to catch up on all the different print statements.
Should we say what like ever df means, for example?
That could be helpful. So the EVA here, I think, stands for extravehicular activity, which would be a helpful thing for anyone using the code to know. I imagine that once someone had got into the code, they'd be likely to already know that acronym. So maybe it's something that you'd put in your README. But that is a very good point. So yes, I think adding it as a comment would be a good idea. Maybe we can put one at the top to say, yeah, good spot, good suggestion. Thank you.
Thank you.
What I'm going to do now is just run the code so that we can see those print statements actually working, hopefully.
I'm just wondering, could you also include like if like printing that it completed a step, but I know it's kind of redundant, but like for example,
Yeah.
like print completed reading JSON file just to make sure, or is it that is it making it very long already? I don't know.
It's
It's a good suggestion. Um,
Yeah, I think that it's good to know when a step's completed. So in this case, you could probably infer where there's been a problem by seeing what the last print statement was. But yeah, if you wanted to print after each step, either as well as or instead of, then that could also be a useful thing to do. So you can see in the terminal, I have start, reading JSON file, saving to CSV file, and plotting cumulative spacewalk duration and saving to the graph file, and then end. So rather than just running the code, having to wait and seeing nothing, we can see what stage the code is at. Okay, so need to make sure that we commit the changes. So I'm just going to look at git status. And because I created this comments.py file to demonstrate the comments, that's coming up in untracked files. So we don't need to track that, but I will git add either data analysis.py, git commit -m, add comments to code, git push origin main. Okay, so our code looks a lot more readable, but it's missing one of the fundamental aspects of software design, which is writing functions for our code. This is one of the main ways that you can organize your code to improve its readability. And the best kind of functions perform a single specific task. And this function can then be called multiple times throughout the code base, but we only need to define it once. Breaking up our code into functions like this is going to make it easier to read and understand. And since functions are reused, it naturally begins to follow the don't repeat yourself principle, which is a software engineering principle that aims to prevent code from becoming overly long and confusing. This makes the software easier to maintain because if a function needs to change, we only need to change the code in that function. We don't need to update it in lots of different places throughout the code base. And also, as we'll learn tomorrow, testing code becomes a lot simpler when code is written in functions. And this is because each function can be individually checked using unit tests to make sure that it's doing what it is intended to do. And that's going to improve our confidence in the software as a whole. So if we look at our code, you'll probably have noticed that it contains different pieces of functionality. The first is reading the data from a JSON file. So this block of code is all about reading the data. Then we convert and save the data in a CSV format, which is this chunk of code, sorry. Then we do some processing to prepare the data for analysis here. And finally, we create a plot to visualize the results. So what we can do is refactor our code so that each of these pieces of functionality is contained within its own function. First of all, we'll do the first two functions together. We're going to define read JSON to data frame and write data frame to CSV. So right at the top, underneath the imports, I'm going to start by defining my first function using def, and then the name of the function, read JSON to data frame. And this function is going to take one argument, the input file. Then what I can do is copy and paste I'm going to copy and paste from the print statement about reading the JSON file down to the drop NA function. So I'll copy that and then get rid of it. Paste it in into the function. And as you'll have seen, I've got a red squiggly line because Python is expecting this to be indented. So let's go ahead and indent the rest of the insides of that function. And we probably want the function to return the data frame. So we can add a line at the bottom saying return either underscore df. Okay, so we wanted to write a second function as well, writing the data frame to CSV. So I can define a function called write data frame to CSV. And this will take two arguments. Firstly, the data frame that we want to use, and secondly, the output file where we want to store our CSV. And we will include this block of code here. It's only really one line of code, but with the print statement and the comment as well. You'll see that I now have a yellow squiggly line under either underscore df, and that's because the data frame argument in our function is df, so we need to update that. So we've created those two functions, and I'll just paste them into the shared doc in case anyone would prefer to copy and paste. Okay, so now we have our functions. We need to actually call them as part of our code so that they'll run. So let's, underneath the start print statement, we can add a comment to say reads the data from JSON file. And here we'll create a variable called either data and assign to that read JSON to data file, data frame applied to the input file. Then we'll convert and export data to the CSV file using the other function that we just created, write data frame to CSV. And VS Code is very helpfully suggesting that's what I might want to use. So if we remember that this function takes two arguments, firstly the data frame, in this case either data, and secondly the output file, which in this case we've already defined as output file. Now I'm getting a lot of yellow squiggly lines here, and that's because we called this either data, but all of these are either underscore df. So what we need to do is update all of these to match the either data here. So I'm going to use that rename symbol function again. Oh no, I can't because so either underscore df hasn't actually been defined as a variable here. It's been introduced without ever being defined. So we need to update all instances to either data. I'll actually use another function here, change all occurrences. And this allows me to edit all of them at once. Which saves quite a lot of time. And what I'll do is just give you the whole.
I actually, so I didn't quite get the change all occurrences. So Eva DF, if I click right click, should I select then change all occurrences and then, but then that also changes Eva DF inside my method.
So inside the
okay, so inside everything is Eva data.
Oh, I see what you mean. Yeah, you're right. I think this may be. No, you're absolutely right. We shouldn't be using change all occurrences here. Good spot. Because we don't want to change either df in this top function. So we need to make sure that it remains as either df in this function, but down here it becomes either data. So in this case, it is probably just a case of going through manually and updating all of those. So what I'm going to do is just I'll copy and paste all of the code at this point into the shared notes document. Yeah, that's a really, really good spot. Because we do want to continue using either df within this first function, but we want to call it either data further down.
Hi, would you mind just quickly summarizing the change? I got lost a bit because I'm not really that quick with changing all the.
Yeah,
of course. Sorry, thank you.
So what I've done here is created two functions. reading the JSON into a data frame and writing the data frame to a CSV. Previously, these were part of the general block of code, but now they're individual functions, and we've called them within the main section of the code. Is that all relatively clear, or would anyone like another part of the code explained, or for me to go through anything again?
It's not really a question, but about what you were doing with changing the variable names. I checked, and apparently, if we use rename symbol, it doesn't go into the functions. So this you can do to avoid having to do it like manually.
If so, in the instance where rename symbol is an option, that's a good
Yeah.
idea. In this case, uh, we hadn't defined either underscore df anywhere outside of the function, so the rename symbol wasn't an option for me within VS Code. So as an example, if I were to just introduce either df here, let's say I'm here, it's not been defined anywhere within the main body of code. So if I right click on it and click rename symbol, I get this element can't be renamed because we haven't defined it within the main block of code.
Mm, okay. Okay.
I see there's a question. Question in the chat, when you call the functions, is it best practice to call them straight after you define them? Or is there a more appropriate time to call them in the script? So we will be looking more at the structure of the overall script a bit later on. So and in the next episode, we'll look at creating a main function where we call all of the functions. So I'd say generally you probably put your functions at the top of the script and then call them later on in a main function or in the in another block of your code. But we will come to that a little bit later. Any other questions at this point?
Could you just explain Eva underscore df? Was that from our original code, right? Just get lost of it. And then with brackets also. These two Evas, yes. Yeah.
So the Eva df, so that used to be the variable that we were using throughout the script, but now we've refactored our code. We're using Eva df as the return from this reads JSON to data frame function. But then when we actually run the function, we're assigning the output to this Eva underscore data. So we could have called this Eva underscore data Eva underscore df instead, but I think it's been called something different to make it clear that we can assign the output of the function to a variable of any name. Does that make it any clearer?
Yep. Thank you.
Okay, great. So if you take, we've got another challenge now. So we've created two functions, but there's still more of our code that could be extracted and put into functions. So in this challenge, it says extract the code to plot a graph into a separate function. The plot cumulative time and space with the arguments data frame and graph file. And then commit and push your changes. So I'll put that into the shared notes document.
Oh, it's there already.
It's there already.
Exercise.
Yeah, perfect. I think it's in a code block, weirdly.
Oh, it looks like it's selected for some reason, but I don't know why.
Okay, so 5 minutes to create the function plot cumulative time in space. And when you've created that function, remember to call it. And it might also be helpful to run your code to just verify that everything's working as expected. Okay, so creating a function for plotting. We want to define this function underneath write data frame to CSV. We can call it plot cumulative time in space. And this is going to take the data frame, so DF as an input, as well as the graph file, so where we want to save the graph. And then we can find our plotting code, copy that, and paste it into the function, remembering to indent. And now we've called the data frame, the argument for the data frame in this function df. So we're going to be renaming either data again to df to match the name of the argument here. So we've created that function. We need to actually call it as well within the main code. So where I had my plotting code before, I will add in the call to the function. So let's add a comment, plot cumulative time spent in space over years. And we'll call the function, which is conveniently recommended to me. Now, you remember it takes two inputs, the data frame and the graph file. Our data frame here is called either underscore data, and the graph file is just called graph file. So I'll save that and run the code again just to make sure it's still working. Okay, so if you manage to extract the plotting functionality into a function and then call that function and your code runs as before, could you give me a green thumbs up? If you've got an error or a problem somewhere, if you can react with a red cross, and we can try and sort out any errors.
Sorry, would you mind going back to the I think you've changed some of the variables, right? The function. Or you could just paste the
Yeah, sure. I'll go over that again. So within plot cumulative time and space, the argument that we're giving to our function is df to stand for the data frame. So this means that all references to the data frame within this function need to be changed to df as well. But then when we actually call the function later on, we want to call it on our data either underscore data. So you can think of df within the function as being kind of a placeholder for the actual data. And then later on, when we call the function, we want to use the actual data frame as the argument. So what I'll do is just, I will put in the shared notes document the current state of the code so that if anyone is getting some errors or would prefer to copy and paste, you can do that from the shared notes document. Okay, probably time for another break now. So if we come back at 11:45, yep, Jen?
Hello. Hope you can hear me now. Um,
Yep.
this is just a very small point, but after I've done the plot cumulative data function call, I did add the print end statement, but I never actually get that statement printed to the um, terminal.
Oh, so you put the print end statement within the function, but it
No,
didn't
no,
print.
I added it after, the same as it is here. Um, but for some reason, after it plots the data, right, it comes up on the side. Then I have to close the little plot separately, and the end statement is always missing. I don't think it's a huge issue, just wondering if anyone else is getting that.
When you so let's have a look at what mine does.
Oh, sorry, I will also
So
say I am calling the Python plot from a separate open terminal, not within VS Code. Don't know if that makes sense.
okay, it might for me, I can see the start and the other three print statements, but I don't see the end statement until I actually close the plot. Is that the same for you?
Sort of, but the end statement just doesn't come up. Okay. Not sure why.
Okay. Maybe if you pop in the chat the setup that you're using, we can we can have a look and try and investigate why that might be the case.
Okay. Oh, sorry, what setup do you mean?
So you mentioned you're running it in a different terminal. So yeah, I suppose if you oh, I think you might have frozen. I'll type a message in the chat. Okay, I hope everyone had a good break. We'll get started again in just a minute or so. Okay, so we've got one more way to improve code readability before we move on to the code structure portion of today, and that is a lot shorter than this, so don't worry. But before we do, the final thing that we can do to improve code readability is to use docstrings to document our functions. So docstrings are a specific type of documentation that's provided within functions and classes in Python. And generally, a function docstring should explain what the code is doing in the function, what the inputs are, and what the outputs are, as well as any errors that might be raised. And docstrings can really improve code readability because it makes others reading the code more easily able to understand what the function does. In terms of the syntax, we write docstrings as a multi-line comment, so the 3 quotation marks. And you'll see that I have now had a pop-up say generate docstring. This is an extension that I've got in VS Code, which very helpfully provides me with the outline of the docstring to write. If you would like to download this extension as well, it's called Auto Docstring. So if you'd like to be able to see the structure of the docstring whenever you type 3 quotation marks, head over to extensions, search for Auto Docstring, and you can install that into your VS Code. So I'll just wait a minute for anyone who wants to install that extension to do so. In terms of what you actually write in the docstring, first of all, we want to write a summary of the function. So in this case, it's reading the JSON to a data frame. So we want to say this function is going to read the data from a JSON file into a pandas data frame. And the last line is also going to remove any rows where duration is missing. So we can add that as well to the docstring. Clean the data by removing any rows where the duration is missing. The next element of the docstring is the arguments. So in this case, input file is our argument, and we can put in the type. So this is the type of data that the argument is. In this case, it's a file or a string. And as a description, we can say this is the file object or the path to the JSON file. Finally, we need to say what the function returns. So in this case, it returns a data frame, either df, and this is a Panda data frame. And as a description, we'll say this is clean data as a data frame structure. So those are the three elements: the summary, the arguments, and what the function returns. We've got a challenge now, which I've just pasted into the shared document, which is to write doc strings for the other two functions that we introduced earlier. So these were write data frame to CSV and plot cumulative time and space. So take 5 minutes or so to write some doc strings for those two functions.
Hi, would you mind scrolling back up? Thank you. Thanks.
Okay, so let's go over some examples of doc strings for those other two functions. So first of all, write data frame to CSV. As a summary of this function, I would say it is going to write the data frame to a CSV file. For the arguments, it takes two arguments, a df, which is of type pandas data frame. So here PD is an abbreviation for pandas. As a description, we can say the input data frame. And the other argument is the output file, which in this case is either a file or string, and it is the file object or path for the output CSV file. Now this function doesn't return anything because it's just saving the CSV file, so we don't need to have a return section for this one. Then if we look at the plot cumulative time and space, one sec. Okay, so here this is going to plot the cumulative time in space over years. And we can break that down a little bit more by saying first we are converting the duration column from strings to number of hours. Then we calculate the cumulative sum of durations. Then generate a plot of cumulative time spent in space over years and save it to the specified location. And the arguments here, we've got two again. df, again, this is a data frame. And this is the input data frame. And we have graph file, a file or string. And this is going to be the file object or path to where we're saving the graph output. Okay, so now we've got three functions. They've all got doc strings, and they're all being called within our main body of code. So throughout this code readability section, we've incrementally improved the readability of the code, and hopefully now it's, at least for me, much easier to understand, and for someone else coming to it for the first time, they would be able to understand what it does and hopefully get it running a little bit faster. So,
Hi, sorry, what's the meaning of returns in this context?
yeah, sure. So returns is what is output by the function. So in this case, the top function read JSON to data frame is going to return a data frame called eva_df. So this is like the output of the function. And when the function's called down here, the the output of this, so the either df will be assigned to this variable either data. Any other questions?
Why didn't we have returns for the other two functions? Just
Good question. The other two functions don't output anything. They don't return anything. Instead, they save things. So for write data frame to CSV, we save the CSV file here. And for the graph, we save the graph and we show the graph on the screen, but it's not something that is an output. It's not an object within Python that's being output from the function. Any other questions at this point? In which case, let's add and commit our codes, and then we'll move on to the next section. So I'll git add either data analysis.py, git commit -m refactor code into functions, and we'll push to main. Okay, so moving on now to code structure. We're first going to look at how we can break down the code into even more functions so that it can be more modular and reusable. So far, we've got 3 functions. And we've seen that each function should have a single clear responsibility. And we should write functions to be as simple as possible so that they can be easily reused or combined to build more complex functionality. We've also seen that functions should accept parameters, which allows them to be more flexible as compared to encoding hard-coded values within the function. So here, for instance, we've given the parameter input file, and then any input file can be used with this function. We haven't hard-coded a particular input file within the function. So we can refactor our code to extract even more code into separate functions. In this case, we're going to add 2 new functions, text to duration and add duration hours. So for ease, I'm going to paste the code for both of these functions into the shared notes document, so you can copy and paste from there. And I'll add these just underneath my existing functions. And we're going to use these extra functions tomorrow when we look more at testing the code. But for now, the only other change to make to the code is within the plotting function. We can use our add duration hours function. So we can say rather than so all of this line here now is enclosed within the add duration hours function. So we can just say df equals add duration hours applied to the data frame. And this is an example of nesting one function within another function. So we've broken down the functionality even more, allowing us to test it and reuse it. So now, even though our code is a bit longer than before, it's more readable, and the new functions that we've added can be potentially used elsewhere and can make our code much easier to test. If you could give me a green tick when you've got those two functions in your code and you've updated the plotting function to use add duration hours. Okay, 8 ticks. If you'd like another minute or so, or a bit more time, if you could react with a red cross and we can wait. Okay, I'm not seeing any red crosses, so we'll keep going. And next we'll talk about how we can restructure the code to create a main function, which is something I mentioned a little bit earlier in response to a question. So there's a common code structure for a main function in Python where you define a function called main, and you include all of that inside of that, everything that you want to run within your code. So probably calling other functions. And then there's this syntax: if name equals main, then run the main function. This is a little bit of Python specific syntax. So in Python, name is assigned to main if you run the script from the terminal. So how we've been running the script throughout today and yesterday, name would be assigned to main, and the main function would run. However, if you instead import your script, so you say import either data analysis, name would be assigned to either data analysis. And therefore, because name isn't main, the main function wouldn't run. And this is really helpful because it allows us to import our code into other scripts without having everything running by default. So let's use that syntax within our own code. So just as a recap, we'll define a function called main, where we'll include everything in our main code at the moment. And then we'll say if name equals main, then run the main function. So when we run the script from the terminal, name will equal main, and this function will run. Okay, so let's try and implement that within our code. I'm going to define main right at the top of the code. Def main. And within our main function, it's going to take 3 parameters: the input file, the output file, and the graph file. So these are the 3 inputs that we have to our code. And then I'm going to scroll down to where the main code is at the moment. So here where we've got print start, and I'm going to copy all of this except for the definitions of the files, because if you remember, we don't want to include hard-coded values within our functions. So I'll just move start below the file assignments, and then I can copy from print start down to print end. And I'm going to paste that into the main function. Making sure that it's properly indented. So now within main, we are reading the JSON to the data frame, writing the data frame to CSV, sorting the values, and then plotting the time and space. I'll make sure that the print end is indented as well. So everything that was in our main block of code, so outside of the functions before, is now contained within the main function. So what I'll do next is at the bottom of the code, I've now got input file, output file, and graph file by themselves there. And I'm going to contain them within the name, if name equals main block. So I'm going to say if double underscore name, double underscore. So that's a special Python variable. If that's equal to double equals sign, double underscore main, double underscore. So if name is equal to main, which means really if this is being called from the terminal, then we'll indent these 3. We want to set the input file equal to either data.json, the output file equal to either data.csv, and the graph file equal to cumulative ethergraph.png. So this is the same as before. It's now just contained within our if name equals main block. So these files will only be assigned if the code is run from the terminal, not if it's imported. And also within this block, we need to actually call the main function. So we'll call main on the 3 files that we've just defined. And I'm just going to run the code to make sure it still works. So if you have created your main function and your if name equals main block, if you can give a green tick. If you'd like me to go over any parts again, just shout out and let me know. Yeah, sure. So question in the chat, give an example of when you would import and when you would run it in the terminal. So you could import this data file into another data file if you wanted to use the functions from it. So I say I didn't want to run the whole analysis, but I want to import the read JSON to data frame function. I could import it into another script, in which case the name would be set to either data analysis. If an example of when I might want to run it from the terminal is if I want to execute the whole data analysis that this script is doing. I'll just give it another minute or so. So I can see we've got eight ticks, and I think we had about 10 or 11 before. Oh, we're up to 10. Okay, another good question in the chat. Why is using main better than just running the whole script? So if you just ran the whole script, then, well, firstly, it would mean that wouldn't be able to import it quite so cleanly. So for instance, so here let me just find it. Yeah, okay, so you generally want your script to be able to be imported by another script so that you can test the functions within it. Or maybe you want to be able to access individual functions for if you're creating an API or something like that. And why you wouldn't just have your code outside of a main function. If you were then to import it, you might have some side effects of the code that's outside of functions being run when you didn't want that to happen. You just wanted it to import the functions. I feel like that wasn't a great answer. Maybe one of the helpers can give a better answer in the chat.
Well, maybe I can try. Or if we've got Steve. He's our most senior research software engineer.
Yeah, so I suppose that's a really good question. I think when using why is it better to use main better than just running the whole script? Is it possible to import certain functions when you use main? I think the most useful thing there is when you're using main is that you're explicitly saying what the high level workflow is for running each part of the code in sequence. So you're explicitly declaring how the code should operate. I mean, you could easily just load this into the terminal, run each function as you needed, and that's good for testing. And it's good for just checking that things work. But keeping things reproducible so that each time you run the script, you have the same behavior is really a really good thing to try and aim for. So explicitly putting into your main the functions in the order in which you should expect to call them means that every time you run it, you'll get the same result. assuming that the Python file itself produces results deterministically, then that's a really good idea. So yeah, in general, it's a good idea to do it that way, just so you're being clear how everything is being called. Does that answer your question?
There is also Stack Overflow answer about why we put things in a main function. And I think another good reason is what Philly said. You can import your script into another script essentially as a library, and you might not think that you would do that now if all of your code is one block, but as the code base grows and you've got thousands and thousands of lines of code, your code will be then split into multiple modules and submodules, and being able to import the functionality from one script into another without actually executing the main part, so just reusing some of the functionalities, so some of the functions is also quite critical, and putting that like Steve said, the main flow of your execution in a separate function then gets executed when it needs to be executed is invaluable for reusing the other parts of your code.
Great. Thank you both for the great explanation. Any other questions before we move on? No? Okay. Okay, so we've got this much more readable, professional looking structure now with the main function and the if name equals main syntax. But at the moment, we can only run our code over specific data files. So we've hard coded into our if name equals main block the input file, output file, and graph file. This is fine if we only have one, such as in this case. But imagine, for example, we were running, we had lots of different data files of the extravehicular data, maybe from different countries, maybe, or from different data sources. And we wanted to run this piece of data analysis over all of them. We'd have to go into our script between each analysis, edit the input file, and that would be quite tedious, time consuming, but also really not good for reproducibility because we're editing our file each time. So a common way to structure our code to make it more flexible, in this case to allow different files, is to give a command line interface to allow the user to specify certain parameters for the code. So in this case, we could allow the user to include the input data file and the output data file on the command line when they run the script. And yeah, this is going to really improve the interoperability of our code, meaning that how it works with other files and other scripts, as well as the reproducibility of the code, as we're not going in and editing the file each time. Another benefit is that it allows us to chain our code in a more complex data analysis pipeline on the command line. And as I mentioned in the instance with having lots of different input data files, we could invoke our script in a loop, running the script over hundreds or even thousands of data files. So to allow us to use command line arguments, we can edit our code and use the sys library. So underneath importing pandas, I will import sys. I don't need to install this package because it's It comes with Python, so we just need to import it. And then head back down to the if name equals main block. And within this block, I'm now going to say if the length of sys.argv, so here this is if the length of the command line arguments is less than 3. So if there are less than 3 command line arguments, then we want to use the default input and output file. However, and we can just add a comment to clarify that. We can say, or a print statement, we can say print using default input and output file names. But if we do have 3 command line arguments, so else we're going to set the input file to sys.argv in square brackets 1. So this is the command line argument with the index of 1. And if you remember, Python's counting from 0, so this is going to be the second command line argument. And for the output file, we will set this to sys.argv2, the third command line argument. And we'll print using custom input and output file names. And we want to keep the graph file the same, whether or not we specify command line arguments, and we want to run main in either case as well. So looking at the logic here, using default input and output file names will only print if there are fewer than 3 command line arguments. And using custom input and output file names will only print if there are 3 command line arguments. So let's give it a go now, specifying the input and the output file. So I can say Python eva dataanalysis.py. So in this case, eva dataanalysis.py is our first command line argument. We were always using it. So that's in index 0 of the command line arguments. But the next argument is going to be our input file, which is the command line argument with the index of 1. In this case, this is eva data.json. And the third argument is going to be eva data.csv. So let's try running that. Oh, I think I forgot to save the file, so that's not going to work. But it did work, but it didn't use the new logic. So let's try saving the file again. Let's run that again. Okay, so the code is run, and you can see that we also get the print statement using custom input and output file names, because the if name equals main block has detected that we have 3 command line arguments.
Hi, sorry, what was the change in the import on top? Sorry about that.
Yeah, sure. The we needed to import one more package, which is import sys, sys. And that is the package that allows us to access the command line arguments down here. Okay, great. So if you have managed to run your script with command line arguments, if you can put a green tick. If there are any problems, errors, questions. I can see one red cross. Yeah, do you want to let us know the error that you're getting? Maybe, yeah, sure. I can copy and paste the whole script into the shared notes doc. So yeah, I have pasted all of the code into the shared notes document. So if anyone has got a typo or got a bit lost, feel free to copy and paste that. Okay, so we have one final way that we can improve the structure of our software. So far, we've just looked at the structure within the code file, but we'll now consider the structure of the directory that the software is stored in. Generally, there are some good practices for setting up a software project. One is having a top-level directory, so everything related to a project in a single directory. Seeing as we're using Git and GitHub, we're kind of forced to do this because everything needs to be within the repository. And then within that top level directory, we want to have subdirectories for things like data, code, results, documentation, and figures. So at the moment, we've just kind of got all of our files floating around within the directory, not organized into subdirectories, but we will sort that out in just a minute. And the other thing is to make sure that our files are named in a consistent way. So here, in this project, we've decided to use hyphens between words in data files and underscores between words in code files. It's, well, either personal preference or the preference of whoever's project that you're working on, what the naming convention is. And as mentioned, yeah, we're using version control on the on our directory, so that's already good. So we've got one final challenge here, which is restructuring the project. We want to restructure so that the input data is stored within the data directory. So that'll be the JSON file stored in a data directory, and the results, so the graph and the CSV, stored in a results directory. And we need to remember to update this both within the folder structure, but also within the code, so where we're asking the input file to come from and the output file to go to. So I'll pop that into the shared notes document. Oh, someone already has. Thank you very much. So take a few minutes to restructure your directory. And maybe if everyone could remove the green tick now and then put it back up when you have restructured your code. And make sure you run it as well to ensure that the code is working at this point. Okay, I can see we've got 5 green ticks. Just a reminder to do a green tick if you have restructured your code, and we'll wait just a couple more minutes. Okay, let's go over the project restructuring. So first of all, we want to make sure our input data is stored in a data directory. So I'm going to use the VS Code interface to create a new folder called data. And then I'll move either data.json into the data folder. And at this point, I'm also going to update my code to make sure that I'm referring to it in the correct place. Then secondly, I want to make sure my graph and CSV file are going to be saved in a results directory. So I need to remember to create a new folder called results. And then I'm going to change the output file to be saved in results/evadata.csv, and the same thing with the graph file as well. And the challenge also says remove the current files, CSV and PNG from the project root if they exist, as they'll be recreated by running the code. So let's delete that one. And let's delete that one. So now hopefully if I run the code, they should be recreated within results in the results folder. But yeah, now if I look in results, that's where the CSV file and the graph have been saved. So that's tidied up our directory a little bit, but we now have these new folders which we need to make sure are tracked in version control. So let's look at the current status. We can see that either data.json is Git thinks it's been deleted from the root, and that's because it's been moved to data, the data folder. And we've modified our either data analysis.py folder, but we've got these 2 new folders, data and results, that we need to make sure are tracked. So we can say git add either data analysis.py and also the folder data and the folder results. So let's add all of those and then git commit -m update the project directory structure. I can see a question in the chat about adding a dot before the folder name, or yeah, before. So a dot just means the current directory, so where we are right now. I can see Alex, you put a message in the chat. I feel like maybe you can explain better than I can.
I can try. Yeah, so the dot refers to the current folder. So the first part, which is dot slash data, is current folder, and then look at the data folder within the current folder, whereas the slash data starts from the root of your operating system. So it's all the way from the top of the hierarchy. So that's not definitely the same. If you type just the data without any dots and slashes, it could be a bit ambiguous. That's why we tend to type the dot slash to make sure that it's interpreted. Look at the data folder within the current folder. The one, just the data, would probably be understood as look at the data folder in the current folder, but it's yeah, we are not 100% sure how different programming languages would interpret that, but most likely it would be the same as using the dot notation. So it's better to be explicit and to avoid any misunderstandings or ambiguities as to what we mean. Sometimes if you are running, you could maybe run your code from another directory, not from the directory where your code is located. In that case, if you don't have this dot data, who knows what the data might mean. It might be the folder from which you're running the code, or maybe the folder where the code resides. So yeah, always best to be explicit about what exactly it is that you mean.
Okay, thank you very much.
Okay, so one last thing to do before we wrap up for today, and that is to push our code up to GitHub. So I'll do git push origin main. And now our code base in its nice readable and well-structured form is version controlled on GitHub, ready for tomorrow. So just to recap everything we've done today, I feel like we've gone over quite a lot of things, a lot of different elements for making the code more readable and more well structured. So it's almost unrecognizable from how it was at 9 a.m. this morning. So we've looked at readability in terms of import statements at the top. We've looked at using meaningful variable names, removing unused variables. We've looked at using functions, comments in our code, and also doc strings on those functions. And then we moved on to the slightly more advanced structure of the overall code, creating a main function and calling that function only if the code is called from the command line using the if name equals main syntax, and then adapting our code to make it more flexible so that we can use command line arguments as well. And of course, just now adapting our directory structure so that it has some subfolders and it's more well structured and easier to read.